Hello and welcome to Advent of Code, day 22. As you can see, I'm a little bit behind in the problems here, but um, I will be on time for day 23 in about 40 minutes. I thought I might just try tackling this problem, which I read earlier, but haven't started to solve. So what we have in this problem here is sort of like a state transition problem. You have a virus kind of thing that starts at a certain node and sort of moves throughout the network, infecting and uninfecting nodes as it does that. And then at the end, how many bursts cause a node to become infected? So this first part I think should be fairly straightforward. So we're talking about a situation. So let's see, do I have after a total of okay, and then so we don't actually have puzzle input. Node infection status. So looks like, it looks like I have to log in. Okay, let's log in. All right. Switch this to this account here. All right, here we go. And so we have puzzle input. Okay. This is bigger than I thought. So we'll save this as input 22. And let's slurp it in here. I guess we can also maybe also split by lines and see what we get. So talking about board here. Yeah, this looks pretty good. So we can get a count of the board 25 and maybe the frequencies of map count to the board. So it should be 25 rows of 25 each. Okay, so then in this case, we know that there's going to be a starting position. I think that what I'm going to do at this outset here is I think that I'm actually going to represent, because the grid is infinite, I think it would be helpful to represent it not as not as just a row, a sequence of rows, but maybe as just like a set of infected nodes and a position. I think that will actually that'll actually be a little bit better. So what I would do in this situation is, so I'm definitely gonna have the board, but I'm gonna say for I in range 25, for J in range 25. For each of these things, I'm gonna say, like, basically if it's a hash when you get in board ij, then we're going to emit the pair ij like this. In fact, I should make this a when here. Okay, and then so let's see. So so like this here, and yeah, I can just put this into a set like this, and then I'll define this to be my starting state. I think this will go a little bit better. Okay, so so the state is going to consist of the set of positions that are turned on, and then also I need to know where the virus is. So so the starting position is going to be 0 to 24. Then starting position is going to be 12, 12. Maybe say starting virus, which has a position and a direction. So let's see, cleaner infected keeps track of the direction that it's facing. Okay, so Moves forward one node. Okay. Left infects the node, turns right. Okay, so it seems like the so it seems like the starting position is up based on this because if you because it's saying that it's turning left. So okay, facing up, and yeah, that seems pretty good. And then like we might have a step function here where we're talking about basically like an x and a y, xy dir, and we'll also talk about the infecteds here, and then some value n. And what are we going to do? So basically, we can ask whether x and y. So is this going to be? So is this okay? Infecteds. So basically, to see if this is in that set. So let infected be this, and then so let's see. Then basically, if it is infected, then we want to sort of take out this x and y from the infecteds here, and then let's see. So then the position is, so we're going to have to do like a rotate of the position. So we have to just basically so let's see, infected, so that it moves and then moves left. Okay, so it turns right, it moves up. Okay. Okay, so we can we'll just call, so let's see, if it is infected, then it turns right. So right of the dir. I'll say let the new dir be if infected, then right, otherwise left of dir, something like this. And then we'll say like, so let's see, would this be easier to talk about an x and y position like that? And then we can say like as pause, let's say. And then we can say move, position, new direction. And then pass along new direction here. And otherwise, we do sort of the same thing, except we're adding. Okay, so so left can just be a map from up to left, from left to down, from down to right, and from right to up. And right is a map from up to right, from right to down, from down to left, and from left to up. And then move, given an xy and a dir, is so our vectors are going to be, in the case of up, I think we'll say like 0, -1, down is 0, +1, left is -1, like this, and right is +1 like that. Okay, and then rather than this just being xy, we'll say position, and then we'll just say map plus x dir pause actually, map v is fine here. All right, so left, right, x, move, and step. All right, so let's talk about calling this thing. So I guess the last thing that we might want to include is some variable c here that includes the number of times that an infection happened, and is initialized to 0. So so running this program, we're basically going to reduce step of, let's see, so we call this starting state, and then 12, 12, up and 0, going off range 10,000. Okay, and so why doesn't this have my C at the end? I think because of this. All right, so this did give us an answer. We can try it. How many bursts cause a node? Okay. All right, not the right answer. Okay, so let's work off this example here. I guess it's what is possible is that this xy here is wrong because like this is correct. Let's just see if that produces a different answer. I wasn't sure whether it would. Let's give this a try. Okay, this does give a different answer, which we can try. In the meantime, what we can do is, yeah, just basically talk about the board 2 here. So let's talk about this. So input, we'll call this 222 here. Okay, and there. So now we have board 2, and then we'll have starting state 2. Okay, and then let's do this. So after 5 bursts, okay, so in 7, so it says out of 7, 5 caused a. Okay, and then but the answer here is 6. Oh, I see. Starting state is wrong. Starting state should be 1, 1. Okay, and then does give the right answer 5. Okay, so let's try this 5240 in this case. Okay, that's the right answer. Got our gold star. Let's go back and look at part 2. All right. So let's see. Clean nodes become weakened. Weakened nodes become infected. Infected nodes become flagged, and flagged nodes become clean. Interesting. Okay. Every node is always in exactly one of the above states. All right. The virus carrier still functions, but now uses the following logic. Okay. Okay. So the main thing, start with the same map with clean and infected. Okay, so I think the main thing that we're going to have to change is that this is going to now have to become a map. And what we'll do is we'll emit a pair of like this here. And yeah, so we'll still call this map the same thing. So all right. So now basically let's have a map called new state where we say infected. Okay, all right, so clean to weakened, weakened to infected, infected to flagged, and flagged to clean. And at this point now, I think it, yeah, this should be fine. What is it actually asking? This many bursts of activity. How many bursts cause a node to become infected? Okay, so I think we probably don't want to maintain clean here because So we're gonna have special handling for it. I don't want the map to get too big. So all right. So the new dir is going to be basically, so let the I'll call this the inf state be this, and then the new dir is a case on inf state if it's if it's weakened, then we just take the original dir. Infected, right of dir. Let's see, flagged, it reverses. Okay, so we can just say right dir. And if it's okay, and then if it's clean, which in this case is going to be nil, then we need this to be left dir. Okay. And then we're also going to have new. Okay, so now, okay, so I'll just say end state is just basically new state given the inf state like this. And then I think we just have to do like a case. Yeah, all right, so I think basically if the end state is, I'm going to say, the lookup fails, then return clean. Okay, and then if the end state is clean, then we need to do this disj here as before. All right, but then move, this is the same, this is the same, this is all the same. Oh, yeah, and then this does want to know, same thing, right? How many bursts result in infection? So maybe a con might be better here, even in case of a con. And then so here we're going to say, is the end state infected? In which case we do this here, except this now becomes an assoc of end state like this. In fact, we could probably just do this whole thing. This is going to be straightforward enough. And then finally, what we need to do is we do the same assoc here. We don't increment our value C. Okay. All right, unable to resolve new state. Okay. And now I think, so let's see, we have our reduce in our starting state like this, except now, okay, so it's this number. And then I think that I really don't want to get all of this stuff, so I'm just going to take the last here, which is the value C. Wrong number has to persistent hash set. Did we not redefine the starting state? There we go. Okay, no matching clause clean. Ah, right. Yes, okay, this is good. All right, and here we go. Okay, a hash map can't be cast to a persistent hash set. Oh, that's right, because it's not disj, it's dissoc. Okay, and here we go. Connect to another REPL here just because I want to time this for a smaller value for n. Okay, so it took about half a second for 1/100th of it. So I think it should take about 50 seconds to produce an answer here. So probably don't have that much longer to wait. I guess I could try 10 times the size. The answer that it produced seems reasonable. You would think that if there are 4 different states and one of them is infected, then this number should be about 1/4. Okay, so this did produce an answer here. It is around 1/4, and let's give it a try. Not the right answer. Okay, so let's check. Okay, so let's compare, I guess, to let's compare it to board 2. Okay, so let's see. So we were talking about starting state 2, get in board 2. Okay, so there, and then oh shoot, yep, I've made this mistake before. Okay, that was it. Basically, yeah, when you change around your starting state, you need to make sure that you change all the relevant pieces. Okay, so just another 50 seconds or so, and we should have our answer. Yeah, I guess I may as well get in this one as well. So this is the one that's going to tell us whether we matched the this number here. So we're expecting this to be the same. And then over here, this is going to be the one that gives our actual answer. Okay, so here is the tentative actual answer. And let's compare to what this thread produces. Didn't produce the right thing. So either, because it produced this. Well, I'm gonna try this anyway, because maybe I did something else wrong. Hey, it was the right answer. Okay, not sure what was going on with the example code, but yeah, maybe just something I just wasn't seeing. But glad to have gotten the 2 stars. Let's see, how long did this take? Out of curiosity, so let me see if I have a report on how long I've been broadcasting here. So started 8:17, and if I look at the leaderboard, I did have the advantage of reading the problem before I started. So it seems like not fast enough. Would have had to have gotten things done at around 8:37. But yeah, a fun problem, fun day, and now just getting ready for day 23. So I'm gonna take a quick break and see you in about 17 minutes. All right, thanks for watching.